Hi viewers, I hope you're doing well. Welcome to my YouTube channel. I am Varun Kulkarni, and in this video, I will be speaking about Neuralink and how it is going to revolutionize brain-computer interaction. I will be talking about the implant by Neuralink, and I will also be talking about the chip, the actual chip which is present inside the Neuralink. So let's get started. So Neuralink is a neurotechnology company which has been founded by Elon Musk. Neuralink aims at upgrading and revolutionizing brain-computer interaction by introducing a chip-based brain-computer interaction wherein a chip is going to be fitted into the brain to monitor the neural activity. N1 is the name of the chip which is going to get implanted. So let us first discuss all the components which are present in this N1 chips implant. First here is a biocompatible enclosure. So this entire implant is enclosed inside a biocompatible enclosure. This biocompatible enclosure ensures that the chip is protected even in very harsh physiological conditions. Another component is battery. So the battery is what gives the power to the implant to operate. It will be charged using wireless charging from an external source. So this battery won't be needing a wired charging. Number three is the chip. So the chip, which is N1, which is the main component of this implant. So this chip is the one which is going to perform the recording of neural activity, about which I'm going to be talking more in the later part of this video. And the final component is a thread. So thread is a very important component because number one, the thread is what minimizes the damage during implantation. And number two, the thread contain electrodes. So there are total 64 threads, and in total, all these 64 threads contain a total of 1024 electrodes, and it is these electrodes which monitor the neural activity. Now, to implant these N1 chip, we need a special type of robot which Neuralink is coming up with. So this robot is going to have an insertion head, and this insertion head is going to have a needle of 40 micrometer diameter made up of helium rhenium element, and this will insert the implant which will be able to penetrate the meninges and the cerebral tissue. I will now be speaking about the overall working of the N1 chip. So N1 chip, what it's basically going to do is that it needs to record the neural activity. So first, it is the electrodes which record the signal which arise, the electric signals which arise due to firing of multiple neurons together. When the multiple neurons together fire, they produce an electrical signal, which from the electrode pass through this N1 chip. These N1 chips have a very first component is they have an array of numerous analog to digital converters. Since the electric signals generated by neurons are analog signals, they first need to be converted to a digital signal which can be read by the chip. So an array of multiple analog to digital converters does this job. And once these digital signal reaches the chip, then a DSP is also present in this chip. So this DSP process the signal for further transmission. And once signal processing is done, then this signal is then wirelessly transmitted from the chip to the part below the ear, near the ear where this has been implemented from. It will be done using wireless communication. Now, which wireless communication protocol is going to be used, that is still unclear, because Neuralink has not given any official information about it yet. But it's an assumption that maybe some low frequency, harmless low frequency wireless communication protocol is going to be used. For example, it could be Zigbee, it could also be a Bluetooth protocol. There is also a possibility that Neuralink might come up with its own separate communication protocol, which is going to be used exclusively for the process of this implanted chip on brain. Speaking of the architecture of this chip, it is still unclear which company is going to manufacture this N1 chip, or which exact architecture is going to be present. However, a very prominent feature, the two very prominent features of this N1 chip are, number one, it has to support multi-core architecture, because the signals are quite complex, because the neural connections are complex. Hence, the signal arising out of them are also going to be complex. So for that, a very strong processing is required, which a multi-core architecture is going to give. Number two, the necessity of parallel processing. Parallel processing is also a must here in case of Neuralink N1 chip, because a lot of signals will be coming. The complexity of the processing is also going to be more. So a parallel processing is also must for this Neuralink N1 chip. However, there seems to be a little disadvantage here, which Neuralink themselves have talked about. A problem is that the electrodes seem to be good at only at capturing signals from which are getting received only by firing of multiple neurons. The electrodes are still not as efficient in capturing signal only from one single neuron. So that is still a challenge which lies ahead. Neuralink really promises. Neuralink is really promising cure of paralysis, cure of speech-based problems, even cure of many mental disorders. It also promises enhanced memory and enhanced brain performing capabilities. So the future definitely looks exciting. So this is what I have spoken about Neuralink. If you have liked this video, do give a thumbs up, share the video, and subscribe to my YouTube channel. I will be coming up with more exciting content. Stay tuned. Thank you.